Because the breath in your lungs is what's keeping you alive today. The oxygen that you need to survive. You can't coast for 20 minutes without oxygen. You must have oxygen. Now, let me give you a little lesson here. I've got my whiteboard here. I'm going to give you a little chemistry lesson today. And so you come to church and you learn a lot. How does the oxygen get to the various cells of your body?
Blood.
The blood. Okay, and there's no other way to get it to all the cells of your body. I mean, your whole body is made up of all these billions and trillions of cells. How are they going to get the oxygen they need? There's one way for that oxygen to be transported to the various parts of your body, and it's through the blood. But here's the problem. Oxygen is a gas, is it not? And oxygen makes up 23% of our atmosphere. We have 76% nitrogen, 23% oxygen, 1% other gases. Now that oxygen cannot go into your blood as a gas. Because here's the problem with it. When you get air in your blood, what happens? You die. Because of the fact that it makes a vapor lock in your heart. It loses pressure, you understand? And that's why you'll see whenever they inject somebody with something out of a syringe, you know how they squeeze out the liquid to make sure that there's no air in the syringe? And I remember when I was a kid, I was watching some kind of a murder mystery thing, and somebody went in the hospital and, you know, put the bubbles in the IV or whatever in order to kill somebody. And I mean, if you injected air into your blood, or if air, and I'm always nervous, whenever I'm at the hospital, you ever look at somebody's IV and you see little bubbles and you're like, I don't know, should I say something or am I going to look like an idiot? But you don't want the person to die, you know, and you didn't tell them. So, you know, any air, any gas in your bloodstream will break that pressure lock as the blood pumps through your heart, and it'll create a vapor lock, and it will give you a heart attack, and you'll die. So the blood cannot transmit the oxygen as a gas. Therefore, the blood has to perform all these miraculous functions to turn the oxygen into something that can be carried solidly through the veins. Now, how does it do it? Well, through the red blood cell, through the hemoglobin. Now, try to follow me. I'm only going to spend a few minutes on this. It's not a science class. But follow me for a few minutes because this is so amazing. Now, let me just first of all show you the most basic chemical formula that most people know, which is the formula, right? Everybody know what this is?
Water.
What is it? Water. Yeah. This is really simple, right? And it means that water is a molecule that's made of 2 hydrogen atoms and 1 oxygen atom, okay? Now, everybody knows this. Everybody's seen this before. It's pretty simple to understand. You learn about it in the basics of chemistry. Well, let me show you a chemical formula that's a little bit more complicated, okay? Here you go. I'm going to write it out for you. I'm still going here. Be patient. Okay, see that atom right there? A little more complicated than H2O, right? 3,032 atoms of carbon, 4,812 hydrogen atoms, 780 nitrogen atoms, 4 iron atoms, 872 oxygen atoms, and 12 atoms of sulfur. This is the molecular formula for the hemoglobin in the red blood cell. And by the way, this is the largest, most complex molecule found in nature. Now, isn't that interesting? Yep. That the most complex thing on this planet, as far as on a molecular level, is your blood. Now, that's pretty mind-boggling, isn't it? I mean, 3,032. I mean, these numbers are huge. But here's what's interesting. You know what the most important part of the formula right here is? This right here. That is what your life is hanging on right now. Why? Because that right there, those 4 atoms of iron, is how your blood carries the oxygen to the cells in your body. And here's how. What happens is the air comes into your lungs. You breathe in a big breath of air in your lungs. And as the air comes into your lungs, the blood takes that oxygen and it takes this iron, and basically these 4 iron atoms literally rust. Because you've heard of things oxidizing when they rust. Iron rusts, doesn't it? And these iron atoms literally rust today. I mean, your blood is filled with rusted metal. That's what's keeping you alive. And so these 4 atoms, in order to bring the oxygen in a solid format, instead of bringing it as a gas, those 4 iron atoms actually rust or oxidize. That way it carries it as a solid, iron oxide. Then it brings it to the cells that need it, and as soon as it gets to the cells that need it, it reverses the process, turns it back into a gas, and puts that oxygen gas into the cell that needs it. But now it has to take away the byproduct, the waste product, which is the carbon dioxide primarily that you're going to breathe out of your lungs. And so the cell goes in, or I'm sorry, the red blood cell goes in, it unrusts itself, drops off the oxygen gas, the O2 atom, then it picks up the load of carbon dioxide, but here's the problem again. Carbon dioxide's a gas. So you can't carry carbon dioxide in the bloodstream. So it has to turn it into a solid as well. So at that point, it hydrates it with H2O and forms bicarbonate. And it forms, well, first it forms carbonic acid, and then the carbonic acid is deadly, it'll kill you. So then it has to instantly neutralize it, turn it into bicarbonate, which then links up to the salt in your bloodstream to form basically baking soda, sodium bicarbonate. Then the baking soda is carried through your blood. Listen to this, baking soda. So it takes a poisonous gas, carbon dioxide, turns it into a carbonic acid, which is also poisonous, which will also kill you. So then it neutralizes it instantly, in a split second. It neutralizes it, turns it into baking soda. You carry the baking soda up to your lungs, but you can't breathe out baking soda. You can just imagine just coughing up baking soda. So, when the blood gets to your lungs, here's the most amazing part of all. When that red blood cell gets to your lungs, it instantly, in a split second, re-puts everything back together into, it has to take it apart again, because it turned it into the solid. It has to put it all back together again, create the carbon dioxide gas, put it into your lungs, and grab another load of oxygen, all in the time that it takes for your blood to go from one end to the other of a blood vessel that is 1/50th of an inch long. And have you ever seen pictures of blood coursing through somebody's veins? It's going pretty fast, right? Boom, 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 boom. And in that time that it just shoots by, it just flies by, this tiny blood vessel, 1/50th, this capillary wall that is 1/50th of an inch long, as it blows by, it just instantly grabs up all the pieces, throws in the carbon dioxide, and it has to perform all these chemical reactions to do that. Grab the oxygen, rust itself, and head in for the next one. And it does all of it in a split second. How? Because of this amazing design. Because of this unbelievably complicated design. And yet the fool has said in his heart, there is no God. This just evolved. This came from nothing. No, it's a miracle. It's amazing. Anybody would look at that is a reasonable person and say, that is amazing. That is unbelievable. That is a marvel of creation. Why is it that in our bodies, the most significant aspect of our lives, and look, there are a lot of other amazing things about how the body works. There are amazing things about how the brain functions. There are amazing things about all the different systems that God has put in our body. We are truly, fearfully, and wonderfully made. But isn't it amazing that the most complicated molecule of all, one of the most amazing processes, and the process upon which our very life depends right now, is the blood. The breath that we breathe is transmitted through the blood. The life of our flesh is in the blood. As soon as the blood stops flowing, we die. Our body dies. Our cells die. As soon as that oxygen is not being delivered, we die. As soon as the breath is gone, we give up the ghost, we're gone. We're dead. Just as significant as the blood is to our body, that's how significant the blood is to our salvation. Just as significant as the blood is to the life of the flesh in our physical life, the blood is just as significant to eternal life. Truly, the life of all flesh is in the blood, and without the shedding of blood, there is no remission of sin. Is there something special about the blood of Christ? Yes, there is.